Okay, guys, welcome to math. Tanya just asked a great question. And if I could give you a crown to wear at home today, I would, because you are doing exactly what I've been training and helping you do all year. You're doing it on your own, Tanya. So you're really showing me you're really ready for fifth grade. So before you got here, if you're just coming in, Tanya said she looked at everything that she was responsible for in math today, which remember in school, we were writing it on a post-it and we kind of just started going through all of the things on Schoology and making sure you have them completed. And she said, I looked at the exit ticket in my packet because that's where you've been completing them. And then she clicked online and they were different. I thought I made a mistake, but then when I went back and looked at it, I remembered that in your exit ticket packet, there's drawing and there's two different types of shading that you have to do to show two equivalent fractions. I thought that that would be rather frustrating to try to do it on your computer. So I found something else that is also practicing equivalent fractions that if you're not in school today, that you're going to be doing. So if you're on the Zoom or if you're watching the video, you won't need your exit ticket packet. You're just going to solve the exit ticket that I have linked for you today. Does that make sense? So you don't have to worry about your packet. If you like to do things on paper, you could print out that page and do it on paper first and then just submit your answers. Maria?
Or can we just like draw some stuff on like a piece of paper that can help us like
Yeah,
draw down the
you
equations?
shouldn't have to draw it because there's pictures on there, but if you're going to use the multiplication to help make the fractions, yep, you can just use scratch paper.
Okay.
Anyone else have any questions before we get started? Okay, I'm going to call off who I have for today. Soren Payton, Maria, Colin, Tessa, Olivia, Tyler, Brooklyn, Sophia, Tanya, Carson, Ilea, Tegan's in school, Finn, Julian Pletcher, Riley, Izzy, Sarah, Trace, and Nina. Anyone at home that I missed this afternoon? Nope. All right, let's get ready to roll then. Okay, so you should have your student workbooks out and open to what page? Colin, what page are we on today, buddy?
17.
Got it. Can you read at the very top of the page for me?
The total length of each tape diagram represents 1. Decompose the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. The first one has been done for you.
Okay, so Colin, you're usually really on the ball with all the math things. So I'm going to ask you my first question of the day, okay? My question for you is, after reading that and after looking at this problem, this type of problem, what do you notice? Something has changed, something that every time we've been seeing a tape diagram and there's a curly bracket at the top, it usually represents something. What's different with what we're doing today?
Normally, in our past lessons, where the curly bracket was, that represented one whole. But now the whole thing represents one whole, and the bracket represents a fraction of the one whole.
Awesome. And you know that the reason why we need to point that out is because if you're still using this shaded piece as your understanding of the whole, you're really going to get confused. So today we were talking a lot about Hershey's bars because that's what these look like to me, because they always already have the little dents for you to break them up. So this is your whole Hershey's bar, your whole Hershey's bar. And in the example, half is shaded and half is shaded. Then we're taking that half and breaking up into smaller pieces. So this would be like, if this was just me and Trace sharing this candy bar, I could split it and we would each get 3. But maybe if me, Trace, and Tessa were splitting it, maybe we want a little bit more. So maybe we break it up into more pieces so that we would have more to share with one another. But as you notice, with both of these, in this example, we decompose the halves into sixths. In this example, we decompose the halves into tenths. The bigger the denominator gets, what happened to the size of your chocolate? The bigger the denominator, Ilea, what happens to the size of the pieces?
Um,
Talk a little louder. I can't hear you, honey.
can you repeat that?
Right. Make sure we're focusing. I see your eyes kind of wandering. Look at your computer and your paper. Both of these are showing 1/2. This is then broken up smaller into sixths, and this one is into tenths. The bigger the denominator, what happens to the sizes of the pieces?
They get, the bigger the denominator is when like you like divide the boxes into smaller parts.
Good. So this one's broken into 10 pieces. So your piece of chocolate's going to be way smaller than if it's broken into 6 because it's the same size bar. You're just breaking it up into more pieces. So that was your example. Now we're going to try letter B. So when you look at letter B, Trace, what fraction right here is shaded in? It tells you above the curly bracket.
1/4.
So that means there's 1/4 here. Here's 2/4, 3/4, and 4/4. That gives us our whole. So right here, we're going to show an equation using 1/4. So now, Trace, if I break up this 1/4 and I'm going to break each fourth into half, what is the new value of each of those boxes?
1/8.
You're correct. How did you get 1/8?
I counted all of them, all of the blocks.
Okay, so that gives me 8. So why did you know that it was 1/8?
Because the box was
Each box represents how many? You're on the right track.
was 1.
Very good. So now, Trace, I'm going to put 1/4 equals. I want you to use addition and put these fractions together for me. How would I do that?
1/8 plus 1/8.
Now you're going to solve that. What is 1/8 plus 1/8?
2/8.
Very good. So now we're saying that 1/4 is equal to 2/8. So now we're going to prove that. Tessa, do you remember how to prove or disprove that 1/4 is equal to 2/8?
Yeah,
What could I do?
you can do 1 times 2 or 1 times 2 and then that equals 2.
Okay, and since we have a 2 there, so far so good. But Tessa, what's the rule? Whatever I multiply the numerator by, what do I have to do to the denominator?
You have to do the same.
Okay, so 4 times 2 equals what?
8.
In this example, we have an 8 there. So this tells me that they are equal. Tessa, what if this would have been a 16? Then would I do 4 times 4 equals 16, or do I keep doing 4 times 2?
You would do 4 times 2, but it wouldn't be equal.
Very good. That was great. I thought I was going to trick you with that one. So even though she knows 4 times 4 is 16, she's not just going to change what she multiplies by so that you do get the answer. If 4 times 2 doesn't equal what's here, that tells her, hold up, these are not equal. I want to show you one other way that I remember doing this when I was in school. And so I think it'll be a nice little tip for you guys. So I'm going to show you a little trick. So here's the fraction 1/4 and 2/8. we're going to make a little butterfly. So I'm going to multiply this numerator by this denominator. Sarah, what's 1 times 8?
8.
Now I'm going to multiply this denominator by this numerator. What's 4 times 2?
8.
If you can take two fractions and cross multiply like this, and you get a whole number, which is same number as the numerator and denominator, then you know you have an equivalent fraction also. So that's like another way to help you check. Okay, so now we know that 1/4 equals 2/8, but there's a ton of fractions that are equivalent to 1/4. So now we're going to try another one. Peyton, here I have 1/4. This example breaks my fourths into fourths. So what would each of these pieces be labeled?
1/16.
4, 8, 12. You're correct. Lots of writing here. So each of these equal 1/16. I'm going to label each of these. If you have this done already, I want you to look at the shaded area and see who can tell me what equation we can write to represent 1/4 decomposed into 16ths. Carson?
1/16 plus 1/16 plus 1/16 plus 1/16.
Carson, what is 1/16 plus 1/16 plus 1/16 plus 1/16?
4/16.
So Carson, which two fractions are we claiming are equal here?
1/4 and 4/16.
So I'm going to write these up here. What could I use to prove?
1 times 4 equals 4, and 4 times 4 equals 16.
So do you think they're equivalent?
Yes.
Okay, Maria, now I want you to use the butterfly and tell me what I would multiply to check Carson's work.
Sorry, I just need to move you guys because I can't really see.
So this is I rewrote the fractions. How can you use that butterfly method to double check? So Carson right here, he proved it with multiplication, so I do believe him, but I just want to see if you can use this new method just to double, triple check.
Okay,
Remember, this is what I did for the 1/4 and 2/8.
so you multiply 1 by 16.
What is 1 times 16?
16.
Okay, now what do I do?
And then you multiply 4 times 4.
And what's that give me?
That gives you 16.
Do you have a whole number here?
Yep,
So are your fractions equal?
1 whole.
Very good. So do you believe that 1/4 equals 4/16?
Yep.
Yep, you are correct. Good job. Okay, so far, do we have any questions with decomposing those fractions? Finding equivalent fractions. Okay, let's go ahead and move on down. We're going to look at number 2A. Finn, can you read the directions for number 2?
It says
The total
the
length.
length of each tape diagram represents 1. Decompose the shaded fractions as the sum of smaller unit fractions.
In at least 2 different ways. So letter A, we have the same fraction here, but we're going to show this decomposed 2 different ways. So Soren, this is my whole right here. Look at the shaded portion. What does the shaded portion represent? What fraction?
Okay, so given the fact that it is going to be doubled the amount.
Well, hold on, you're jumping ahead. I just want you to count how many total pieces you have, count how many are shaded, and tell me what fraction this represents.
Okay, so there are four. Well, there are four. There are four columns, or four squares, and you have 1/4, 2/4, 3/4, and 4/4. And 3 of those are shaded.
Mm-hmm.
So
So how
you
would I-
have 3/4.
Do you see the same thing over here?
Yes.
Okay, so we're gonna label both of these 3/4. Now, Sophia, I want you to look at letter A. You're going to get to choose, and there's no wrong answer here. The only thing I'm going to tell you is the more pieces you break it up into, the smaller they are, and then we're going to have to write a ton of fractions. So I want you to choose how many pieces you want to now break 3/4 into. So you want to break these in half, into thirds, fourths, fifths, sixths, seventh, eighth. It could be anything you want.
Let's just break them into half.
Okay, you're taking it easy on me on a Friday. Thank you. So I'm going to take each of these fourths and break them in half. So Sophia, what does each one of these now represent?
They each represent 1/8.
1/8. Very good. So we took our fourths, decomposed them into eighths. So now this is 3/4 right here. The shaded area shows 3/4 and a lot of eighths. We're going to count them so that we can figure out what it equals. So Sophia, go ahead and count these up for me.
1/8, 2/8, 3/8, 4/8, 5/8, and 6/8.
So right now, Sophia, it looks like based on your shading, what two fractions are equal?
6/8 and 3/4 and 6/8.
Okay, so right here, I'm going to write 3/4 and 6/8. Tanya, how can I check to see if 3/4 is equal to 6/8?
You could do 3 times 2.
And what is 3 times 2?
6.
Okay, and that's right here. So I multiplied the 3 by 2, so what must I multiply the 4 by?
2.
What is 4 times 2?
4 times 2 is 8.
So does 3/4 equal 6/8?
Yes.
It does. And almost like our arrows kind of look like equal signs. So I'm just going to leave those there. So 3/4 is equal to 6/8. Now, Izzy, we're going to find another way, something other than 6/8 that also equals 3/4. So Sophia broke up each of these into halves. What's another way we could break them up?
Into fourths.
All right, so now I need to split each of these into 4 pieces. Trying to do it as equally as I can, even though I know it's probably not perfect. Okay, so after, I'll give you guys a second, because I know that's a lot of lines. Izzy, what should each of these pieces be labeled?
1/16.
1/16. Okay, so I still know that this is 3/4, but now I've decomposed 3/4 into a lot of 16ths. So Izzy, count these up for me and tell me how many 16ths is the same as 3/4. Hold on. Before you count, let's try something. I'm going to cover this up. So this is kind of like what your exit ticket's like. So right now, Izzy broke this up into 16ths. We're gonna do this reverse style. So Izzy, 4. So right now we know that 3/4 equals something of 16ths. We don't know how many. They're all here. There's lots of them. Looks like piano keys. 4 times what gives me 16?
4.
So now we need to do the same to the numerator. What's 3 times 4?
12.
Okay, so right now, Izzy, using multiplication, we're saying that 3/4 is equal to what?
12/16.
Now you count them out, and we're going to check this way this time. Go.
1/16, 2/16, 3/16, 4/16, 5/16, 7/16.
6/16, 7/16. This would be 8.
8/16, 9/16, 10/16, 11/16, 12/16.
Look at that. We figured it out before we even counted, and then counted to check our work. Nice job. So what two numbers, Riley, is 3/4 also equal to? What 2 fractions? 12/16 and what else?
6/8.
6/8. All 3 of these that I just circled are all equal. So that means if you ordered a pizza, if I was going to eat 3/4 of it, if it had 4 pieces, I would be eating 3 of them. If I still wanted to eat 3/4, if it had 8 pieces, I'd have to eat 6 of them. If the pizza had 16 total pieces, I'd have to eat 12. The number changes, but the base remains the same. I'm still eating 3/4 of it. The same amount would be gone from my box. Okay, can I flip the page? Is anyone still working? Okay, Tyler, you have your what, you ready to work?
Yes.
Okay, I want you to read number 3 for me.
Draw tape diagrams to prove the following
Statements.
statements. The first one has been done for you.
So the first one, they drew a tape diagram and shaded 2 fifths. Then they turned the fifths into tenths and showed that they were the same. Tyler, do you have your workbook in front of you?
Yes.
Okay, so we're going to skip down to letter C. We're going to do C and then one on the next page. Actually, you can pick. Do you want to do C or D?
You choose.
The only reason I kind of want to do D is because my marker bled up here, but it really does. Let's do D. Okay, read letter D for me.
3/4/16.
Okay, so the first thing I need to draw, and you need to draw at home, is 3/4. How would I do that? What do I draw first?
Draw a R.
Good, a tape diagram. And I'm just going to go with what's behind there. I can kind of trace it. Okay, so here's my tape diagram. If I want to show 3/4, how many pieces should I break it into?
4ths.
Good. So I'm going to try as best as I can to make them equal. So I have 4 pieces here. How do I show 3/4?
Shade in 3 of the 4ths.
Very good. So I'm going to neatly shade in purple 1/4, 2/4, and 3/4. I'm going to label this on top as 3/4. Good job. Okay, Olivia, what's my next fraction?
6/12.
No, on letter D?
Or 12/16.
Very good. So now, Olivia, I had fourths here. Now I need to have how many pieces?
16.
How many? If I have 4 now and I need to get 16, I need to turn each of these into how many more pieces?
4.
Very good.
And-
So if I break this into 4, I would have 4, and then 8, and then 12, and then 16. So I took my fourths and I now created 16ths. Olivia, with the fraction 12/16, how many of these 16 do I need to shade?
Um, 12.
Okay, so now I'm going to take my red. Actually, we'll switch over to black. Now I'm going to shade in 12. So I got skinny bars now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to label this side of my tape diagram 12/16. Julian Pletcher, what do you notice about the purple shading and the black shading?
They're equal?
They're the same. So Julian, how would I write that as an equation? So look at what you have on the top and the bottom and think about what symbol means that they're the same thing.
3/4 equals 12/16.
Very good. Now, Julian, do you remember how I can use multiplication to prove that this is true? You can pick either the numerator or the denominator to start with. It's up to you. Just remember, whatever you do to one, you have to do to the other.
3 times 4.
What is 3 times 4, honey?
12.
Okay, so far so good. So now what do I have to multiply the denominator by?
4.
What's 4 times 4?
16.
So do we have a true statement here?
Yes.
Great job. Very good. How's everyone doing? Questions? Unmute yourself if you have a question. If I can help with anything. Anyone see Miss Jameson come in today at all? No? All right, go flip your book over. We're going to do number 4. This time, I'm going to unshare. I'm going to read it to you, and I'm going to give you a couple minutes to try this one, and then we'll check it together, okay? So for number 4, it says, show that 1/2 is equivalent to 6/12 using a tape diagram and a number sentence. So you're going to do exactly what we just did. You're going to draw a tape diagram and label it 1/2. Then turn it into 6/12. Okay? Okay, I'm going to set a timer for, I'm going to give you three minutes of work time. I'll share my screen so that you can see. 3 minutes, and then we'll check. And if we need to fix anything up, we'll fix it up together, okay? All right. You don't have to rush to get it done. We're just going to keep us on time so that we have time to check and answer any other questions.
Miss Shevchik, which one is it again?
Number 4.
Okay.
If you have any questions, just unmute yourself and ask. So you're showing in the picture that 1/2 is equivalent to 6/12. So you should have 1/2 represented on the top part of your diagram, tape diagram, and 6/12 represented on the bottom. And then see if you can use multiplication, a multiplication equation to prove it off to the side. And I'll give you a little bit more of a challenge. After you do that, see if you can use that fancy butterfly method to see if it equals 1/2. So you can triple check. You have a picture, an equation, and cross multiplication. About 20 seconds. All right, let's go ahead and check. All right, who's someone I haven't got to talk to yet today? Brooklyn. All right, Brooklyn. What did you do to draw 1/2?
I drew a rectangle, and then I put 6 lines.
Well, we first want to show 1/2. So how many pieces do I divide it into for 1/2?
2.
2. And how many of these should I shade?
1.
Good job. So this right here is 1/2. Okay, now who else haven't I got to talk to yet today? Nina, go ahead and unmute yourself and tell me how I turn this 1/2 into 12ths. How do I turn each of these halves, well, I guess total, into 12ths?
So in each half you can draw, you split the first half into 6 pieces. And then you split the second half into 6 pieces.
One, 2, 3, 4, 5, 6. Not my best equal shading. 1, 2, 3, 4, 5, 6. Now, Nina, how do I show 6/12? How many do I shade?
What was the question? I'm sorry.
How do I show 6/12? How much do I shade?
You already shaded in all that you need to shade.
Okay, so I have 1, 2, 3, 4, 5. All 6 pieces are shaded. So now I can label this side 6/12. Carson, how can I show that 1/2 is equal to 6/12 using multiplication? Carson, are you there? Carson, unmute yourself. Either he's frozen or he's having a staring contest with someone. What in the world? There you are. You're back.
Okay. 1/2 times 6/12 is 1 times 6 equals 6, and 2 times 6 equals 12.
So is it a true sentence?
Yes.
It is. It's equal. Finn, can you tell me how we can use cross multiplication to check our work?
Well, first we have to circle the 1 and the 12. And we do 1 times 12 is 12. And we circle the 2 and the 6. And 2 times 6 is 12. And 12 twelfths equals 1 whole.
Great job. The half ones I think we're pretty good at. So you guys use a lot of halves in everyday life. Okay, do we have any questions? Okay, so I'm going to pull up your exit ticket for you for those of you who maybe didn't notice that it was different than the lesson. Or, I mean, it's the same concept. It's just a different paper. So you have to fill in what's missing here. So you have to figure out how many fourths. 3/4 is equal to how many eighths. The first three, there's pictures done for you. The other ones, you're going to have to use multiplication, maybe your own drawings, draw some tape diagrams. So you have A through O. Your job is to put a number in each of these boxes. Okay? So just give you some practice with equivalent fractions where you don't have to submit any drawings to me. But like Maria said, what if we needed to make a drawing to figure it out? Absolutely. Go ahead and do that. You just don't have to submit it to me. Okay? Any questions? Anyone have any exciting plans for the weekend?